Today, we are going to consider the question, just how does a steam boiler work? To find the answer, let's go to the Bavarian town of Gunzenhausen to the company Bosch Industriekessel GmbH. Bosch Industriekessel GmbH has sold more than 100,000 industrial boiler systems around the world. That's roughly the number of hairs that the average brown-haired person has on their head. Internationally known companies like Coca-Cola, Nestle, Red Bull, Unilever, Daimler, Volkswagen, Pepsi-Cola, Ajip, Heineken, Shell, Haribo, Balzen, Arla, BMW, Philip Morris, and many others are all loyal customers of Bosch. And there's a good reason for that. Bosch uses modular components in its boiler systems, which makes them easier to set up and to operate. That's true for its steam boilers, hot water boilers, and heating boiler systems. Now this is all very well, but what good do boilers like this do anyone? Heat is the basis of all life. You can see this when your fridge breaks down and your yogurt comes to life. Just a little joke. If the sun was our only source of heat, huge areas of the globe would not be habitable for humans. Depending on where they are on the Earth and at what time of year, humans therefore need to produce heat artificially, in other words, without access to energy from the sun, in order to survive. There are also all sorts of technical processes that need heat to work. The food and drink industry uses steam boilers for cooking and cleaning, but lots of other products from the building materials, chemical, and textile industries simply could not be produced without heat. As you can see, we humans would find life very difficult without heat, and heat from steam boilers in particular. Fine. But how exactly does a steam boiler work? Let's take a closer look. To help us understand, let's take an ordinary saucepan because, essentially, a saucepan does the same thing as a steam boiler. Hey, in the mood for some tasty potatoes? First, we'll put some cold water in the pan and put the potatoes in it. Next, we don't carry the pan into the desert and let the sun cook our potatoes. No. We use a cooker, of course. Don't forget to turn it on. The water will start slowly heating up, and later, we'll have lovely, flavorsome potatoes. As you can see, the water is getting hotter and hotter. As we get close to the 100 degrees Celsius mark, we can see bubbles of steam forming on the bottom of the pan. These steam bubbles get bigger and bigger until they become less dense than the water around them. This makes them float to the top of the water, and the water starts bubbling. The water has now reached boiling point. From now on, even though the pan is still being heated up by the cooker, the water will not get any hotter. But just why is that? Simple. The steam bubbles, which contain large amounts of heat, are floating to the surface and leaving the saucepan. In our saucepan, the boiling point of the water was 100 degrees Celsius, but the boiling point can change depending on the ambient pressure. The lower the pressure, the lower the temperature at which water will boil. For example, on the top of Mount Everest, the highest mountain in the world, ambient pressure is very low. If you boiled yourself an egg there, all the water would boil away before the egg was cooked through. This is because water there boils at 70 rather than 100 degrees Celsius. But we want our potatoes to be cooked as soon as possible, so we need to raise the pressure in our saucepan. We can do this simply by placing a lid on the pan to make it airtight. Now, the steam bubbles are no longer able to escape, so the pressure increases in the pan just as we wanted. But be careful, our saucepan can't withstand all that much pressure, so we need a safety valve where the excess steam can escape. Now the temperature of our water is 120 degrees Celsius. As you'll remember, originally we couldn't get it above 100 degrees Celsius. Now our potatoes can cook faster than before. So we've learned something. We can now also deduce that most of the energy in the pan is in the steam, not the water. But if there's more energy in the steam than in the water, wouldn't it be better to cook our potatoes in only steam? Let's try it! Let's take a big pan of boiling water and put a little pan next to it with no water in it. We'll link up the two pans with a tube. We'll put our potatoes in the small saucepan. The pan containing the boiling water produces steam, which floats up and passes along the tube into the small pan, straight to the potatoes. When the steam goes into the small pan and cools down on the surface of the potatoes, it condenses and releases heat, which is transferred to the potatoes. The condensation then drips down and runs out through an opening in the bottom of the pan. After all, we want our potatoes to be in steam, not water. Now we're getting closer and closer to understanding how a steam boiler works, but we're not quite there yet. We can't continue our experiment with the saucepan forever because the water in our big saucepan is gradually evaporating away. If the water boils away completely, the energy from the hob will no longer have anywhere to go and will build up in the bottom of the pan and could damage it. So let's add another element to our experiment. We need to make sure that we don't run out of water, so we'll connect a pump to our saucepan to maintain a fresh supply of water. This pump needs to be fitted with a gauge and control device to control the amount of water that it pumps in. Great, but our setup is still not particularly energy efficient. You will remember that excess steam is still being let out through a safety valve. We actually only want this to happen under certain circumstances. To be able to control this, we need a pressure sensor. The sensor measures the pressure in the saucepan, and we can then set the power of the hob so that the actual pressure is slightly less than the pressure needed to open the safety valve. If less steam is needed in the saucepan, the hob is turned down. If more steam is required, the hob is turned up. So is that everything a steam boiler needs to work properly? It's not quite that simple. If we leave our setup to run for a while, we will notice that scum forms on the surface of the water. Why is that? Standard tap water contains salt. When tap water evaporates, the salt remains in the water that is left behind. This concentrates to form scum. We don't want the scum because it's still partly water, so if it goes into the small pan, then it might do a good job of salting our potatoes, but it will also stop them from cooking as quickly because the steam will no longer be able to reach them directly. So how can we stop this scum from forming? We use a gauge to check the salt content of the water. If we find there is too much salty water in the saucepan, we can let this out through a special valve and pump in fresh water with a normal salt content in its place. As if the scum wasn't bad enough, after a few weeks, sludge starts to form on the bottom of the pan. The problem here is that the sludge covers the whole of the bottom of the pan and so blocks the flow of heat from the hob to the water. So somehow we need to get rid of the sludge. But how? With a valve, of course. Every so often we open the valve for a few seconds and the sludge runs out. Last but not least, we insulate our saucepan with cotton wool so that as little heat as possible can escape, and voila! We now know how a steam boiler works. Here's how a steam boiler from Bosch Industrie Kessel GmbH really looks. Quite different from our saucepan, isn't it? That's because this boiler is not powered by electricity, but by liquid or gaseous fuels such as natural gas or light fuel oil. A real steam boiler also needs to handle much higher pressures than our saucepan, and it also needs to have a much higher output. To compare, our saucepan can generate around 1 kilogram of steam every hour. That's about the weight of a 1-liter bottle of cola. A steam boiler, on the other hand, produces up to 55 tons of steam per hour. That's more than 4,000 crates of cola, or around 7 lorries full. If it wasn't for the Industrial Revolution and the invention of the steam boiler, it wouldn't be possible to buy a car today at an affordable price. And clothes, drinks, and even paper and food as we know them would simply not be available. So a great big thank you is due to Bosch Industriekessel GmbH, and thank you very much for watching. Warm wishes.